Thanks for joining me. In this video, we are going to discuss the quadratic formula. So when you're solving a quadratic equation, and here is kind of the basic form, right? When you're solving a quadratic equation, you may have already learned about solving using the square root property and or solving using factoring. But sometimes the factoring doesn't work and the square root property doesn't work for everyone. There's also completing the square method, so you might have learned that. Completing the square works for every quadratic equation. And if you complete the square on a generic quadratic equation, you will get the quadratic formula. So you can derive this formula from completing the square. We won't do that in this video, but we're just going to go ahead and use the formula. So this formula, because it's derived from completing the square, and completing the square works for any quadratic equation, this will work for any quadratic equation. The key is to make sure that you have your equation set equal to 0 before you try to use the formula. If not, it's not going to work out properly. So let's look and see how to use the formula. So let's make some connections first. Notice that the letter in front of the x squared is the a, the letter in front of the x is the b, and then the one without an x is c, that's the constant. If you have it in descending order, meaning your x squared is first, and then x is second, and then the constant is last, the a, b, and c will be in order. But if your equation is not in descending order, you'll have to be careful to make sure you pick the appropriate coefficients for a and b, and that the constant is c. So keep that in mind when you're working through these. So the directions say solve. If the solution is not an integer, give both an exact answer and a decimal rounded to the nearest thousandth. So if we tried another method, like let's say we tried to factor this one, you would find pretty quickly that this is not factorable. So another method to try would be completing the square, and you could do that if you'd like, it would work. Or we can try to use the quadratic formula. So I think a good habit to be in is to write the formula down before you start trying to plug in numbers. So x equals the opposite of b plus or minus the square root of b squared minus 4ac all over 2a. And now we're just going to plug in the numbers. Notice that my equation is in descending order. So a is the number in front of x squared. There's not a number, so it's understood to be 1. B is the number in front of x, so it's 11. And c is the constant, it's 6. Also, I didn't note verbally that there's a 0 on the right-hand side of the equal sign. So that's something to make sure that you have the equation set up in this way prior to plugging in the numbers. Okay, so negative b is 11, so negative b would be negative 11, plus or minus the square root of b squared, so 11 squared, minus 4 times a, which is 1, times c, which is 6, all over 2 times a, which is 1. So we have negative 11 plus or minus the square root. 11 squared is 121. And then 4 times 1 times 6 is 24. So minus 24 all over 2 times 1 is 2. Continue to simplify under the radical. So negative 11 plus or minus the square root. 121 minus 24 is 97. All over 2. So at this point, you would want to try to reduce the square root of 97 if you could. You cannot do that. So this is your final exact answer. Or I should say these are your final exact answers because you have 2. So keep in mind that this means negative 11 plus square root of 97 over 2. And negative 11 minus the square root of 97 over 2. These are your exact answers. And so an easier or more efficient way to write this is with the plus or minus, like I did in red. But it might help to write them separately in some cases, just to see that you have two. And it's also helpful if you have to actually find a decimal or rounded or approximation, which is what we have to do next. So in order to do that, you're just going to type these in your calculator and figure out what you would get as an estimate. So you would find the square root of 97. Then you would add that to a negative 11 and divide by 2. So for that one, I get negative 0. And it says round to the nearest thousandth. So that would be 576. Okay, and then the bottom one, you would do the square root of 97. That's a minus, so that's a negative, plus a negative 11 divided by 2, and I get negative 10.424. So those are my rounded answers, or in other words, they're estimates. So make sure you're paying attention to how they want your answers. If they want exact form, you should do what's in blue. If they want an estimate, make sure you round to the appropriate decimal place. For the next example, this one is a little more complicated. The first one, it was all nice and set up for us. It was a descending order on the left. It was 0 on the right. That's great. That's obviously not going to happen all the time. So what we want to do here is get it set up before we start trying to use the formula. So first, let's distribute on the right-hand side. The left-hand side, I could put it in descending order if I wanted. So x squared minus 3x plus 5 is equal to 5x squared minus 5x. Okay, and so now I want to combine everything on one side because it's a quadratic equation, and I'm going to try to use the formula. So I'm just going to go ahead and subtract 5x squared from both sides. Since I'm using the formula, it doesn't matter if the x squared is positive or not. If I was going to try to factor, I would really want my x squared term to be positive, so I would be moving everything to the right-hand side. So if I combine like terms, I'm going to get negative 4x squared plus 2x plus 5 is equal to 0. It's in descending order. I have it set equal to 0. So at this point, I can identify A, negative 4, B, which is 2, and C, which is 5. And so I'm just going to plug those into my formula. So start by writing your formula. X equals negative B plus or minus the square root of B squared minus 4AC all over 2A. So negative B, so that'll be a negative 2 plus or minus the square root of 2 squared minus 4 times negative 4 times 5 all over 2 times negative 4. So remember that you're going to completely simplify what's in the radical first, and you can also multiply the denominator. So 2 squared is 4. A negative 4 times a negative 4 times 5, well, it's going to be plus 80 all over 2 times negative 4 is negative 8. We can add up what's in or what's under the radical. So we will get negative 2 plus or minus the square root of 84 all over negative 8. And now we want to reduce the square root of 84. So your calculator may do this for you. If it doesn't, you can make a factor tree. So divide it by, let's say, 2. You could divide it by anything that you see that goes into it evenly. So if I divide it by 2, I get 42. 42 is divisible by 2, that's 21. 21 is divisible by 3, that's 7. So I've got a prime factor tree, Anything that's a pair will come out of the radical, and anything that's not a pair will stay under the radical. So this is going to become 2 on the outside times the square root of 3 times 7 stays underneath. And so you simply multiply those back together. So the square root of 84 simplifies to 2 times the square root of 21. So I'm going to use that and rewrite my fraction. So 2 square root 21 all over negative 8. So last, I want to look and see if all of my terms have a common factor. So for these problems, you can look for a triangle or a heart. All 3 pieces must have a common factor. If they don't, then you cannot reduce. So if this was a 3, 2, 3, and 8 do not all have a common factor. You would not be able to just reduce the 2 and 8. That's not acceptable. You have to be able to reduce all of the terms. So I can reduce all of these by a 2. So negative 2 divided by 2 is 1. 2 divided by 2 is 1. And 8 divided by 2 is 4. So that's going to leave me with negative 1 plus or minus the 1 square root 21. I don't have to write the 1 in front of the square root. It's understood to be there. Divided by negative 4. It's okay if you notice that the 1 in the front, the 1 is negative and the 4 is negative, so you make them both positive. But if you leave them both negative, that's fine as well. So this would be acceptable, or this would be acceptable. Okay, so those are the exact answers. Remember that you have to find the approximate answers as well. So I'm going to write out both exact answers separately. So the exact answers I get, negative 1 plus the square root of 21 over negative 4, and negative 1 minus the square root of 21 over negative 4. Those are the exact answers. And I'm just going to type those into my calculator and find the estimates. And it asks us to round to the nearest thousandth. So it's 3 numbers after the decimal place. So for the first one, negative 1 plus the square root of 21 over negative 4, I got negative 0.896. And for the other one, negative 1 minus the square root of 21 over negative 4, I got 1.396.